Welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm your host, Richard Restuccia, and today we're going to be talking about soil surfactants again. And I add the again to that because we brought it on as a subject a few months ago, coming into a drought, or really coming out of a drought. I'm not sure where we are on this 20-year mega drought, but it certainly appears that water management is becoming more and more important. And sometimes we are reaching beyond what we think traditional water management is to something even better or different. So we talked about soil surfactants with Mike Terry a few months ago, got his impressions, right? He works for Precision Labs. But then I was thinking, you know what? We've got a guy on our staff at Jane, Cory. He's a certified irrigation designer. He's a certified crop advisor. He knows a lot more about agriculture than just irrigation. And he's a great presenter. And he's got a lot of experience with this product. So I thought, let's have Cory on and find out his impressions of, do soil surfactants work? Do they save water? What exactly do they do for growers? So Cory, welcome and thanks for taking this on. We really appreciate this. And I just wanted to say first, or ask first, how is the season starting for everybody?
Well, it's a good question. And again, thank you for having me as always. And I would say, it's definitely heating up, pun intended. We're talking about 102 degrees in the middle of next week here across the valley. It's been pretty warm overall the last week and a half. I think probably one of the most interesting things is having been here since I'll say 2001, most of my life. I look at it. I don't remember it being this windy this often. I feel like the wind is kind of nonstop at this point, and forgive me for those of you who may be in other parts of the country that actually have quote wind that might be 20, 30, 40 miles an hour. To us, wind might be 10 to 15 miles an hour, but even then I've seen it up into the 20s and sustained that way. So it's been kind of interesting to see what that's brought on. Wind obviously affects ET, and you talked about water management. So not only is the temperature affecting it, but the wind is too. So it's something that growers are accounting for. To your earlier point, it's been hard as water managers. It's been hard for growers, given some of the challenges with supply constraints for surface water. You talk about some of the largest water districts not supplying any. I know that the canal that runs directly behind my house finally got starting to get charged for the first time this year. So we're going to get water in June and in July, which is kind of interesting because last year we only got water in June. So despite there still being less rainfall this winter and less snowpack, we're actually getting more water. It's just due to an accounting type system. But overall, the crop looks pretty good. Obviously, it'll be down a little bit due to some of the freeze damage and things, kind of speaking specifically to almonds, but they seem to be progressing well. Pistachios are moving along. I cut some nuts open earlier this week. I don't know if you saw the post online, but there's some embryos developing in there. So they're moving along. Grape clusters are pushing. Tomatoes are out there. So it's, as always, we find a way to make it work here in the valley and just try and provide as much food as we can for the rest of the world.
Yeah, I'm glad you mentioned that about wind, Cory. It's really important, right? And a lot of people don't. I'm teaching a couple classes at the Water Conservation Garden in San Diego this week, and we really started talking about all the factors of ET, because most people just think, well, is it hotter or cooler, and that's ET, but it's not. And 17 factors, but wind being a really important one. And I think everybody's learning that when they have wind at a time they don't normally have it, or when they have 50-mile-an-hour winds when they're used to having 10 to 15.
Absolutely. No, it is shifting. That is kind of a shift in priorities and demand. So again, it's just something I've noticed recently, being out in the field a lot, working with growers, managing water for people. It's something I've had to pay more attention to.
Yeah. So, well, listen, we're really excited to learn about your experience, right? This is what we're really getting today, and that's really valuable, your experience the past few months, not to mention very generous of you to share that with us.
No, I appreciate it. I think to your earlier point, when we talk about soil surfactants, and kind of where does this fit in with what we're doing as a company, and where does this partnership with Precision Labs? And I think it's really speaks to what we're doing as a group to sit down and say, how can we take as many things as we can out of the toolbox to really help take water management to the next level, to where, if you look at it from like a holistic standpoint, I'm at the Fresno facility right now, and there's a lot of people that work here. There's a lot of products that get made right here. And we spend all this time engineering and building and designing and shipping these products and work really hard to get them out into the field. And then you start coupling that with water recommendations from our water management services team, using our Jane Logic software, putting in probes, getting satellite data, doing all these different things. I think we're remiss if we don't look at other opportunities to keep going, to really package this all together. Because even if you build the best irrigation system with the best products, sometimes there's still things that can be improved upon. And as a company, we sat back and said, let's look at some opportunities for that. And surfactants have been one of them. I've personally used them, and kind of wanted to share some of the stories that I found, the way that I'm looking at it as a water manager for somebody, as a business partner with somebody, trying to say, hey, how can we leverage these things, and what's the ROI, and what's the value of doing this?
Yeah, no, I love that, right? Always looking to be better.
Absolutely.
And that's great. So, and I just want to remind everybody, if you want to learn more from Cory and ask some questions, put them into the Q&A or in the chat, and I'll be passing those on to Cory as we go along here. But those windows are certainly open and available for you.
I appreciate that. And, I spoke about Precision Labs earlier, as did you, and Mike Terry, who's a great representative of that company. They have a great team. They've been in business for a long time, making a number of different products. And so I kind of pulled this from their website just to kind of give a quick background on them. And, they're, again, focused on helping growers, retailers, golf course superintendents. I've seen this product out on golf courses before when I've been playing, turf grass managers, for sports. And so, again, focusing on feeding the world, creating these outdoor spaces that, folks like you do on the landscape team, Richard, that allow us all to enjoy and decompress. Again, one thing we all have in common is we're all stewards of the earth. And so, again, agriculture, landscape, sports, turf, and then I kind of broke out a few things. Spray adjuvants is one of Precision Laboratories' most notable lines of products that they carry. And it's really neat that when we started having discussions with them, to see the companies that they're working with. And that tells me a lot about the reputation of that company and what they're building because of who their retailers are and who they're selling to. And then again, a line of this that we're going to talk about today, we talked about surfactants. Probably one of the easiest ways is IWO, Irrigation Water Optimizer. It's kind of a cool term. May seem strange at first. Probably most people have heard of surfactants, especially if you're a grower. But IWOs are kind of some unique chemistries that we're starting to offer here, and something that again, we have some pretty positive experience with.
Yeah, very cool. Yeah, IWO. That's much easier to say too. But I tried this out at my house as well, Cory, and I was really happy with the results. My soil was holding on to water a lot longer than I wanted it to, and this certainly changed that for me.
That's perfect, because we're going to talk about that and the opposite end of that spectrum today. And so again, when I talk to growers, I spend a lot of time in the field. I have a lot of connections, whether it's Farm Bureau, Young Farmers and Ranchers, the normal day job. I talk about these things and what we can do better. And so they say, well, why optimize my water? You're going to talk about these IWOs. Why are we going down this road? And obviously, as you alluded to earlier, there's multiple years of drought. Brought increased risk to agriculture. We all know that. Generally, we can just irrigate our way out of it. But obviously now with Sigma, there's going to be kind of this long-term insecurity of water deliveries, especially in certain parts of the state. And it's going to require us to create more crop per drop, right? Which is uniquely kind of our slogan as a company. And I was with a grower last week, and he was told that he can only pump 28 inches of water, and he has no surface water coming. So when you look at an almond tree that might be asking for 40 to 44 inches of water during the growing season, you might have a couple of inches residual in the soil profile. Making those numbers meet is going to be really tough. And trying to find anything you can to help save or help maximize every drop will be super important. As you alluded to earlier, also, the cost of water has increased significantly. The value of water has increased significantly, meaning what it could be sold for, what it could be used for. Today in California has changed tremendously. So, of course, that's driven up the cost. Then there's the cost of labor, if you can even find it. It's very real. These are probably 1A and 1B, it seems like, when I talk to most growers and what they're most concerned about. And it's what I see most companies trying to solve is water and labor. And then one thing that's always important, and it's probably, I don't want to say forgotten, but it's something we've been used to, but the cost and regulation of crop nutrients. You think of the regulation around something like nitrogen. Yeah, it's probably the biggest target, but it's also one of how many nutrients that are being applied on a pretty mass scale, if you all things considered. And so regulation is probably coming for some of these other ones. And so, there's the compliance part of it, but there's also the cost of it. We know about inflation, we know about availability, and the price of nitrogen has gone through the roof in the last 2 years. So these are the things that I think about. And this is kind of where taking IWOs into account, depending on your scenario and what you have going on, could really make a difference.
Hey, Cory, that was interesting. Who told this grower 28 inches this year or 28 feet this year? Was it the water agency or?
Yep, it was the GSA, the Groundwater Sustainability Agency, which is a governing body kind of created by Sigma.
And had this grower ever experienced something like that before?
Nope. Like I said, we as a group could generally irrigate our way out of a quote drought. And unfortunately, there's a multitude of reasons why we're in the position we are. That would be that'd be a 7-part webinar series we'd probably have to do. But, it's, you can agree or disagree with it, and I'll reserve judgment, but it's real. And so we have to understand that. And so try and open the toolbox, like I said, to new perspectives and new methods to making things work.
Yeah, and I understand the reason for the message. The timing's kind of worrisome.
Yeah, I mean, but you think about how many growers there are and how many APN numbers and what boundaries are in these areas that they have to cover. I mean, there's a lot of things that need to get handled. There's a lot of work that has to go into it. So I can understand, I'll say the poor timing. It doesn't maybe excuse it, but it's a challenge. And like I said, these are the conversations that are being had on a weekly basis in the field or at the coffee shop.
Yeah, no, it's definitely a challenge. We're all pulling together to figure it out too, and that's great to see.
Absolutely. And so, we talk about water savings, and that kind of gets brought up a lot. I think the way I really like to look at it again is kind of this maximization and really kind of limiting the losses. And you use loss kind of loosely, but with drip micro, generally the ways that you're going to see it lost is going to be leaching. I also put kind of plant unavailable in there because maybe it didn't quote leach all the way to like groundwater or something like that. But if it's beyond what the crop can actually use from a spatial standpoint, it's probably not very beneficial, right? When you think about lost is beneficially used or unbeneficially used. And then the second way is evaporation or runoff, even on low volume systems. You can see these things happen. I was driving out west last week, and in the morning, probably about 6:30 in the morning, the sun was coming through the bottom of the orchard, and I could see somebody with micro sprinklers. And the original pattern was probably, 6 feet off each side of the tree row. But between the rows, it was probably 80% covered in water because it had just glassed over and just ran all the way across. And there was probably only 20% of the orchard floor that wasn't covered. And I don't know how deep it was, but I can tell you that there was a decent volume of water waiting for the sun to come up and evaporate most of it. And you see these things from time to time. And so, there's a irrigation scheduling issue maybe, but then there could be a soil quality issue and application rate. There's a number of things, but it's common enough. And again, we see a lot of systems that aren't designed to fit soil properties. It's just designed based on, well, my pump does X, so that's what we'll apply. And even low application rate systems can easily push water beyond the crop root zone. And obviously that's going to waste the nutrients, the water, the energy, the pump to pump it all, the labor. So that's something we need to focus on. An example of that, a sandy loamy sand soil, which is kind of, I say, the makeup of my neighborhood. It influences, I'll say, tens of thousands of acres around me. The infiltration rate can be well over 2 inches per hour. And that water can move pretty quick, even if you're not putting, quote, a lot on in a given period.
Yeah, that's a pretty fast penetration rate there.
No, and it's real, and I don't think we don't realize it until maybe it's too late, or we install equipment to kind of learn. And so, an example to kind of fight something like this, a real life example from an orchard that I manage personally, I applied a product called Stretta, and Stretta is pretty neat. It's cellulose. It's essentially like a plant material with some other non-plant materials, and I kind of, for layman's terms, say it's liquid organic matter. It improves the soil condition, allowing it to hold more water, and then make that plant available, make it releasable. And so I have an orchard that I manage. It's 22 foot by 16 foot, very common standard spacing, fine sandy loam soil. It's double line drip, half gallon at 30 inch. Of course, it's all Jane products. And before applying Stretta, we had infiltration rates of 2.4 plus inches per hour. So it would go very quick. And half gallon 30 is not that much water per acre, especially from an application rate standpoint. So in a 24-hour set, water would easily go way past 48 inches, which was kind of the bottom end of our management zone. And so to meet orchard demand during peak season, peak ET, which would be coming up in the next month or so, and still keep it above that 4 foot we talked about, we'd have to irrigate every day or every other day, just in shorter sets. And a ton of work to get out there, turn it on, turn it off, check it. Just one of those things that, installing drip was meant to make things easier. And again, it was more efficient, but in order to keep that efficiency, a lot of work had to go into it. So we use Stretta to help improve those soil conditions, hold that water, and then also hold those nutrients that we are applying via fertigation.
Yeah, so Cory, we've got a question coming in, and the question is this. I thought that soil surfactants helped water move through soil, but they actually do both.
It's interesting. So that's great. We're going to jump into in a little bit kind of the opposite end of the spectrum, which is to help water get in and move through soil. And then we have some hybrid products. And the unique thing is we're only carrying 4 products. Basically, one to hold, which is Stretta, one to get through, which is Quicken. And then there's a few products in the middle, Domino and Tolero, that are kind of closely related from a chemistry standpoint, but just stacked a little bit differently that, to give you a golf reference, right, is a rescue hybrid, something that can kind of get you out of a tricky situation. And so that's kind of really unique that we can offer that. So it's something that needs to be tailored, something that needs to have a professional recommendation, in my opinion, somebody with experience to help you maximize it. But yeah, it's really cool that we can see both working. Stretta is a really unique product. There's no chemistry like it on the market that I've seen. And from my experience, it works extremely well. And,
yeah, good to know. So Stretta helps you hang on to the water.
Absolutely. And here's some visuals of that. This is some probe data from our GeneLogic software with our infiltration widget. And obviously there's kind of these big blue wakes on the left-hand side that you can see, but really kind of focusing down to the actual information that's tangible. And I even had gone back to as far as last year, because we've been managing this field for multiple years. So the top chart is from April of 2021, and the bottom chart is from April of 2022. I was trying to make things as even as possible, show kind of the spatial and temporal variability of it. But you can see before Stretta, we would apply a 10.5-hour irrigation event and we'd get to 40-inch depth. Our average infiltration rate was 2.9 inches per hour. Whereas after applying Stretta, we could run a 26-hour irrigation event. We'd get to 28 inches for roughly an average of 1 inch per hour infiltration rate. Wow. And, that was, again, started by applying 2 quarts of Stretta per acre, which is the high end in the initial label rate. And the results, again, were near instant within an irrigation event or two. And so applying Strata for us allowed us to run longer sets so we could do less labor, increase that water use efficiency because we're making it all more plant available. Almonds are, I'll say, luxury consumers. They really enjoy all that water and nutrient right at the top, I'll say 18 to 24 inches. And then nutrient retention, or say a majority of the feeder roots are in that 18-inch range to 24-inch range also. So kind of keeping all the food and all the water right there seems to work really well. Since then, we've made a second application to Strata 4 weeks later at the lower rate of 1 quart per acre, and that has maintained the results that we saw originally.
That's the thing that always surprises me is 1 quart per acre. It seems like nothing. How could it possibly make a difference?
Well, I think when you look at the way we're irrigating and treating the soil with the system too, in that we're applying it directly into the water, we're applying it directly into the soil profile area that's holding or managing the water, for a lack of better words, to begin with. So even though there's 43,560 square feet per acre of above ground, and then 4 feet deep, and then you math that out on a volume, and that's a lot of soil, a lot of digging. You think about it, and you can really kind of treat the area in which you're actually managing anyways. Because that's where all the fertility is going. And that's where, especially in a sandy profile, it's very vertical. There's not much lateral.
Right. Yeah, interesting. So the drip irrigation portion of this really makes a difference.
Absolutely. And so I just went through some examples, just to kind of talk about. I was in an orchard last week doing some DU tests and flushing systems, and thinking about management, thinking about labor and spending time, and because I had to explain to somebody that they probably needed to flush a little more often. And so if I went through and I just came up with this example, but if labor is $20 an hour, and that might be generous at this point, and I have to irrigate 48 hours in a week, which is exactly what I'm doing this week. If my limit to hit 48 inches before was 18 hours of runtime, I'd have to run basically 3 irrigation sets this week. At 1.5 hours per irrigation event for labor standpoint of driving to the field, driving back to turn it off later, to maybe spend a little time making sure everything's up and running. That's $90 a week. And now if I Strata and I go to 2 times a week, that's now $60. So I could save $30 a week. I could essentially put $120 a month in my pocket right off the bat. So that's just, and again, with fuel and everything else right now, I feel like $20 an hour on labor is pretty reasonable. And especially when you think about some of these smaller fields that need to be managed just as much as a big field does, you can apply a pretty low amount of product like you just talked about, Richard, and kind of see these instant results where you usually see scalability for growers. Unfortunately, it takes 160 or 300 acres for something to kind of start penciling out. This is something that can actually help a lot of the small growers right away too, a 20, 40 acre type scenario.
Well, that's the other thing, Cory, it's not that expensive.
It's really not. It's just the ROI, the cost effectiveness, it's all there. And that's, what I'm illustrating, right? And this is actually from our field. This is the lab results that we got back. And, if you're the bar graph visual type, basically everything's green except potassium, which is high. That's great because we applied KTS and we wanted to make that plant available. It got up into the plant, and that's going to be super helpful as things get hotter. Potassium will definitely help those trees kind of manage that situation. But, I look at the fertility results of what we're doing with us running twice a week and holding that water better, and only fertigating once a week. And we're doing it on the second irrigation event of the week, halfway through it, so that we're running fresh water and up and running. Then we're fertigating. And then at the end, we're running a little bit of fresh water. And I don't have that worry of pushing that material too far down because we're timing it right. And then we're also essentially slowing down the soil in the process too. And then it's sitting there, plant available, which obviously this report shows you. So kind of maximizing those inputs and talking about that, if nitrogen's $1 a pound and almonds are just say 250 units per acre, it's $250 an acre. And these are things that I think about while I drive and talk to people and work with these systems is, well, what's 1% of that loss? If we're in a scenario where there are some suppressed commodity prices, now it's time to stop the bleeding and increase the efficiency. So if I have a 1% loss, it's $250 an acre. If it's 5%, it's $1250, and so on and so forth. And this is just some math that I've done on my own and just thought about, if the UC recommends 68 pounds of N per 1,000 pounds of kernel that are being removed, you think about nitrogen, it's already technically inefficient in that, 15% of it, we kind of say gets lost to volatilization, chemical changes. So if you lost 5% and you've already basically accounted for and paid for the 15% that you knew was going to kind of disappear in the system, and you lose an additional 5, that could be 12.5 pounds based on the 68. And if you think about the 68 in correlation to 1,000 pounds of kernels, and you factor in those inefficiencies, do you lose 100 pounds of kernels per acre? And is that at $1.70 a pound? And does that end up being $170 an acre with 5% loss? So heck, what if it's only 2.5%? I'll give you half of that. That's still going to be $85 an acre. I mean, those are the things that we need to think about and consider as the overall inputs have gotten more expensive, and there's probably no end in sight for that in a little bit, especially with compressed commodity prices.
Yeah, it's fascinating, right? This is the dollar saved is a dollar earned too. I mean, it goes right to the bottom line.
Absolutely. And so that's kind of our use case for Strata and what we've done there. And again, super passionate about it, very happy with the product. And again, something that I have personal experience with applying, delivering, and managing. It's very, very personal for me at this point. And so that's why I was happy to talk about it. And kind of to the earlier question, I've gone the other route with some other growers that I work with and using a product called Quicken, which is a great name because it tells you exactly what it does. It's an infiltration aid, helping get water and those nutrients we just talked about into the soil where they can become effective. Obviously, we talked about the evaporative loss earlier. It could be as high as 20% of the soil wetted volume. So that on the surface, that's something we definitely don't want to see water sitting out there. I told you it's going to be windy and it's going to be 102. So let's avoid that. And really infiltration problems. I mean, there's a number of reasons they can exist, but you could have clay or essentially tight soils that are going to limit that infiltration. You could have an excessive or high application rate compared to what your soil can just take in general. You could have poor soil structure, so salt or lack of organic matter. And then you could also have pure water, which, there's really no electrical charge, no minerals in it, nothing to positively charge and bond to that negative soil. So the water just sits on top of it and it has no way to get in.
Yeah, it's interesting, Cory. We have a question on this evaporative loss.
Yeah.
So they're trying to get clarification. If water is just sitting out there in a field, you can lose a fifth of it in a day, in an hour, in...
So there's different ways of approaching that, and I'm glad that this is getting asked. I think there could be a little more research on it in general. The way that I've always studied it, understood it, and it's been described to me is that if you think about the way that we're irrigating, and so like in this case, if I'm applying it with drip irrigation and I have kind of this narrow wetted band, and say that I'm wetting 20% of the soil surface between the tree rows, and it's exposed to the elements, the sun, the wind, so on and so forth. And you think about that, maybe we have most of these rows are 1/4 mile rows, so 1,320 feet. And I have a 22-foot tree row, and now I have 20% of that. You think about how much area of that 43,560 square feet I talked about earlier is now wet and exposed. It's no different than you irrigating your lawn at 1 p.m. when it's very hot, although San Diego is usually pretty nice. But that's not the most effective time to water. And I'm sure that you'll probably talk about that at the Master Gardener class this weekend. The theory is that you can lose a decent percentage of that water applied based on the volume of soil that is wet and sitting in the sun or sitting exposed to the elements.
Yeah. Yeah. Thank you for that clarification, because 20% is a lot.
Well, and then you think about what if somebody's irrigating with a full coverage sprinkler, which has its merits in certain cases. But is there a way to combine those two systems to be more efficient? Where I see more growers that were traditionally on jets adding single or double line drips so that they can irrigate early in the season and fertigate more efficiently and not expose it to these wider areas and temperatures.
Yeah.
So looking at Quicken, this is a picture that I took a couple hours after applying product in a peach orchard a few hours north of here. And so you can kind of see those little wetted kind of ball banded areas. Traditionally, this would already be kind of running farther to the right of the photo off the berm and also maybe running into each other. The grower has this pure water condition that we talked about, which doesn't seem like many growers have that problem here. But it certainly still exists. And so he's pulling water off of a nearby river, and he'd say that he would have standing water for days in his peaches. And so we applied Quicken at 3 quarts per acre, which is the high end of the label, into a double line drip, half gallon 30, again, a very common setup for a lot of crops here across the valley. Now we ran the system for 24 hours to kind of really put it through its tests and merit. And I can say that after we injected the product at the beginning of the set, it was visible in the field within 30 minutes. And then we went through and we ran, based on my calculations, 0.81 inches of water. So a decent amount of water into this ground. And this was a text message pictures and the text message text that I got from the grower, which was water would stand in these spots for days. It's gone, just about gone 24 hours later. Which was really neat to kind of, work with this grower, talk to him. It's somebody I've never worked with before, but have definitely known and seemed pleased. Again, there was very small amounts of ponding, but considering the challenges that were ahead, the kind of tightness and firmness of the soil overall, and what his original issues were, we felt like it was very successful.
Yeah, Cory, what does that mean? Product was visible in the field in about 30 minutes.
Great.
It's a clear product. How do you see it?
Yeah, you can actually see here, if you can see my cursor, but you kind of see this white spot right here. This is actually a little bubbling or foaming. This is an alcohol-based product. And so you're going to see some foaming out in the field. There'll be some pictures that I'll show on this next slide that'll maybe be even a little bit more clear than that. And but yeah, you can physically see it coming out of the emitter and its interaction with the air and the soil. So it's kind of nice because it gives you a really good way to check to make sure that it's coming out where you want it to come out and actively working. So a great question on that also, because I was a little shocked the first time too.
Yeah, and wow, look at this photo. I hope this is before.
Yeah, so this is this is pistachios in Western Kings County. This is actually salt affected soil. So we applied Quicken on 175 acres of pistachios in Kings County. And you walk on this soil and it's like walking on like cake. Its structure is very poor. Obviously, it's already a clay loam soil, and then we have this salinity issue. This infiltration is pretty poor. We actually kind of wanted to work the other way, and we put on 3/10, which is just over a quart, which is the low end of the rate, just to kind of prove a point per acre. And the injection was completed in about 45 minutes. And we ran a 24-hour irrigation event. We had ran about an hour to 2 hours before we applied, and then we applied over a 1 hour period. Again, trying to get it as much towards the front end of the irrigation as we could. So we ran 24 hours. This actually had 1 gallon emitters on it, which again, in heavier, poor drained soils, you can imagine what that normally would look like. And so you can see in the picture here, you see a little bit of the ponding down at the bottom end. That was from the original run of the first 2 hours of the irrigation. But then you can actually see the foaming coming out of the product and its interaction. So that material was visible within 20 minutes. And I'll say it started working. The grower comments the following day were that there were not a drop of water standing the next day when we shut it off. It was wet, but it wasn't standing. And I think it's important to note, as I mentioned earlier about professional recommendation, varying rates of product are needed for different challenges. And that's one thing that's really nice is it has have a large label rate of 1 to 3 quarts per acre. And again, we talked about the economics of it. This is actually our least expensive chemistry offering that we have. And so, it's been, I'll say, a treat to work with also, because it can really help some of these growers who have these challenges, because you can go put on as much water as you want, but if it doesn't actually get into the ground, it's not really helping.
Yeah, what a photo here too. I mean, the proof is in that photo, that's for sure. So let's see, we've got a question coming in. How much EC is considered a salty soil? I think that's the question.
Yeah, great question. You'll have to forgive me. I don't have my EC chart memorized. How about that? I mean, you look at it, and this is probably the worst section of the field by far, but you can understand that it's in there, and even in some of these other areas like this where you don't see it maybe visibly on the surface, we can dig down about 18 inches, maybe even less, and you can see the salt that has kind of had some rain impact and has kind of forced its way down in a little bit. This is where I think Quicken can help with remediation, in the sense that salt moves with water, and so if we can get the water moving through the soil profile, traditionally growers had to apply a lot of water, try and use calcium because it has twice the electrical charge as far as sodium does, to kind of displace it from the soil colloid and then kind of move it down through the profile. I see this as maybe something that can also help in those type of scenarios, and again, continue to help remediate soils. It's not a miracle cure or a fix-all, but it's certainly something in that toolbox, like we talked about, to maximize that water we're using for leaching. So if you want to get the person's information who's talking about the EC, I'd be more than happy to follow up with them.
Yeah, great, Cory, and thank you. And I think you make a really good point here that it isn't a one item fixes all, right? But we've got to use every tool we have right now with the way things are going. So somebody had a chart or a really good memory, and they said 2.5 and higher EC is considered salty soil.
I will take it, and I don't have the soil test for that particular field, but it's probably a little higher than 2.5. And like I said, if you can walk on it and it bounces up and down like a trampoline, you've got some structure issues.
Yeah, that's a really big red flag waving. And making noise. So, Cory, as usual, you have been fantastic today. I love the way you took us through, some real world experience that you have had, and the positive success as a result of that. And I know that we'll all be considering more seriously, or I imagine there's a few that are already going to be motivated to try some soil surfactants on their properties and on their ranches and farms going forward. So thanks so much for sharing this information with us.
No, thanks for, again, the platform, the opportunity. I want to thank Precision Labs for all their support. They've been, anytime I've had a question, anytime I've had an idea, they've gone to grower meetings with me. They've really helped support their product. They're proud of it. And that's what really, I think, is going to make this partnership work in the long run, is their investment in this process as well. And couple that with our abilities, our expertise. It's kind of a match made in heaven.
Yeah. Well, great. Thank you again, Cory. Thanks to all of you who attended. Really appreciate you spending a little bit of your day with us. And as you know, you can find all our trainings at janesusa.com/trainings, or wherever you listen to your favorite podcast. So, Cory, stay cool this weekend and enjoy your weekend, and we'll catch up with you next week. Thanks again, everybody.